Hello, in this video, we want to do a quick review on synthetic division and the remainder theorem. This is a full package on everything you need to know about these terms and their relationship and application. First of all, I want you to remember about the factor theorem, which says x minus c is a factor of a polynomial f of x if and only if f evaluated at c is equal to 0. So given a polynomial f of x, if we evaluate f of x at c, we get 0, then x minus c is said to be a factor of f of x. In other words, when we divide f of x by x minus c, there is no remainder. Okay. The remainder theorem tells us to say if f of x is divided by x minus a, remember I'm using a here deliberately because a can be any real number. So if we divide it by x minus a, then the remainder is given by f of a. You can see that in the factor theorem here, f of a, I'm using c, f of c is equal to 0, meaning that x minus a is a factor in that regard. Let us give a quick example by examining whether x plus 1 is a factor of this given polynomial. So given x plus 1, what is the value of c? The value of c is very simple. You just solve x plus 1 equal to 0 implies x is equal to negative 1. So we are going to use the factor theorem. So we are going to see what is the value of this function evaluated at negative 1. So this is 2 negative 1 power 3 minus 3 negative 1 squared plus 4 negative 1 minus 1. And already this is this gives negative 2, this is minus 3, this is minus 4, this is minus 1. So you can see this is negative 5, this is negative 5. So this gives negative 10. We can say since f at negative 1 is equal to negative 10, which is not equal to 0, therefore x plus 1 is not a factor of f of x. In the same way, we can use what we call synthetic division to divide this polynomial by this given factor. So what we do is very simple. We are going to do the way we do long division. However, synthetic division, I'm going to take the coefficients in this polynomial. So I have 2, negative 3, 4, and negative 1. Then remember we solved for c here, which is negative 1. So negative 1 is the one that we put here. Then we bring down the 2. Okay. Here we are going to be adding. So we take negative 1 multiplied by 2 is negative 2. When we add negative 2 and negative 3, we get negative 5. Negative 1 multiplied by negative 5 is positive 5. 4 plus 5 is 9. Negative 1 multiplied by 9 is negative 9. And negative 9 minus 1 is negative 10. And so negative 10 is the remainder. Now, you can see that after dividing this polynomial by x plus 1, we have this coefficient. So we could write our f of x to be equal to, so the highest power here was 3, and we're going to reduce this 3 by 1. So this becomes 2x squared minus 5x plus 9. Okay, so this is 2x squared, then minus 5x plus 9. Then the remainder is, we said, negative. Okay, so this is minus, then the remainder is 10 divided by x uh, plus 1, in that order. Okay, our next question, we want to again use synthetic division to simplify x is power 5 minus 1 over x minus 1. Okay, so again, we are going to draw that, and you can see that here x minus 1 is equal to 0. Okay, so x is equal to 1, which is our c. So we are going to put 1 here. Now this is x power 5, right? So the coefficient is 1. Then we have x power 4, which the coefficient is 0, x power 3, x power 2, then x power 1, and negative 1. So in other words, what I've just written here is that x power 5 minus 1 can be written as x power 5 plus x power, 0 x power 4 plus 0 x power 3 plus 0 x power 2 plus 0 x, then minus 1. So this is the same thing. Okay, and we get the coefficients 1, 0, 0, 0, 0, which are these zeros, and negative 1. Okay, next thing, we are going to drop this one, as I said earlier. Okay, then we are going to be adding. So 1 multiplied by 1 is 1. 0 plus 1, we have 1. We have 1 here again, 1 here again, 1 here again, 1 here again. 1, 1, and 1 multiplied by 1 is 1. Negative 1 plus 1 is 0. So you can see here that the remainder is 0, meaning that x minus 1 is a factor of x power 5 minus 1. So therefore, we can write as x power 5 minus 1 over x minus 1 is just the same as, so the highest power here was 5, so we are going to reduce it by 1. So this is x power 4 plus x power 3 plus x squared plus uh, x, then plus 1. So this is the first coefficient, power 4, power 3, power 2, power 1, then 1 constant. Okay, so plus 0 because the remainder is 0. Very good. Now, let us look at a different flavor of this problem. Now we want to decide whether x minus 2 and x plus 3 are factors of this given polynomial. And why are we doing this? Because we want to factorize this polynomial, okay, or this function. So x minus 2, solving for x is equal to, x minus 2 equal to 0, solving for x is 2. So we are going to say 2 here, okay. Then I'll pull out the coefficients. This is 2, 7, negative 4, negative 27, and negative 18. All right. Now we're going to drop this 2 here, and we are going to be adding here. So 2 multiplied by 2 is 4. 4 plus 7 is 11. 11 multiplied by 2 is 22. 22 minus 4, because I'm saying negative 4 plus 22 is 18. Then 18 multiplied by 2 is 36. Negative 27 plus 36 is 9, and 2 by 9 is 18. Negative 18 plus 18 is 0. So the remainder is 0 in this case, meaning that x minus 2 is a factor of the given polynomial. Okay? Next, we are going to write the given polynomial in factor form. So we have f of x now is equal to, so this was to the power 4. We are going to reduce it by 1. So this is 2x power 3 plus 11x power 2 plus 18x plus 9. Then we are going to multiply it by x minus 2. Okay. Now we want to see if x plus 3 is a factor. So if you want, you can use the original polynomial, or we can use this factor that we have found a new factor. So I will go ahead and use the new factor. So our c in x plus 3 is negative 3, and we are going to extract here. We have the coefficients 11, 18, and 9. So straight away we drop the 2. Okay, then we do the product. We have negative 6, then 11 plus 11 plus negative 6, yes, is 5. Then negative 3 by 5 is negative 15. If we add there, we get 3. Negative 3 by 3 is negative 9. When we add, we get 0. So meaning that x plus 3 is a factor. Okay, so we are saying x plus 3 is also a factor. Now we're going to write our result here. This is 2. Okay, we reduce the power by 2, so this is x squared, then plus 5x plus 3. All right. Now the question says hence or otherwise factorize. So we have x minus 2, we have x plus 3, then we can multiply this now by x minus 2, x plus 3. Okay, so this is our polynomial. But remember, 2x squared plus 5x plus 3 can also be factorized. So we can just go ahead and do factorization. Plus 5x plus 2. You can see that plus 3. You can see that the product is 6 and the sum is 5. So you could say 2x squared. I can add plus 2x plus 3x plus 3. Okay, so 2x is common here. I remain with x plus 1. Then I can factor out 3 here and remain with x plus 1. So this factorizes to 2x plus 3 and x plus 1. All right. So therefore, our polynomial, which was 2x power 4 plus 7x power 3 minus 4x squared minus 727x minus 18 becomes, so the first factor we said it was x minus 2, and the second one is x plus 3, And the third one is 2x plus 3. And the last one is x plus 1. So this is how the given function factorizes. All right. Now let us see how we apply all these things together. So given that we are saying if 2x power 3 minus 2kx squared minus 3x minus 2 is divided by x minus 2, the remainder is 40. The question is determine the value of k. So we are going to use the remainder theorem. Remember we said x minus c is a factor of a polynomial if and only if f evaluated at c is equal to 0. Okay? So our given polynomial is this polynomial here. So we are saying x minus 2 is equal to 0, so which implies x is equal to 2. So 2 is our c. So the question says if this polynomial f is evaluated at 2, the remainder is 40. Okay, now what is the value of k? So I will go ahead and evaluate our f at 2. So this is 2. Where there is x, I just substitute, I put 2. So this is 2 power 3 minus 2k we are looking for. Then 2 squared minus 3, 2 minus 2. All right. Now 2 power 3 is 8 multiplied by 2 is 16 minus this is 4. This is 2 squared, which is 4 multiplied by 2 is 8. K minus this is negative 6 minus 2 becomes 8. Okay. So this simplifies to this is 16 minus 8 is 8 minus 8k. All right. Now let us put the pieces together. When we evaluate the given function at 2, we are getting 8 minus 8k. But we are told that the remainder is 40. So this 8 minus 4k should give us 40. So what we are saying is 8 minus 8k is equal to 40. Okay, so you can see that we can just divide throughout by 8 and get 1 minus k is equal to 5, which implies that k is equal to, solving for k, we have negative 4. Okay, so this polynomial has the value of k, which is negative 4. All right. Now let us look at this exciting problem, a very good flavor, which is the last question in this set. So given that x minus k is a factor of the polynomial p of x equal to kx power 3 minus 3x squared minus 5kx minus 9, where k is a real number. The question is find the possible values of k. All right, so what are we going to do? We have been given that x minus k is a factor. So remember, you are equating this to 0, which implies that x is equal to k. Now we are going to use the factor theorem as well. Okay, so since x minus k is a factor, then then this polynomial evaluated at k is equal to 0. Okay? Now, what is p at k? So where there is x, in this polynomial, I put k. So this is k on k power 3 minus, so I'll just go ahead and write. So this is k power 3 multiplied by k is k power 4, and this is 3k squared minus, this is 5k squared minus 9. Okay, now this simplifies to k power 4 minus 8k squared minus 9. Now since k is, since x minus k is the remainder, we said the polynomial evaluated at k gives us 0, which we stated here. This implies that if we solve k power 4, k power 4, 8k squared minus 9 should give us 0. Okay. Next, what do we do? Because we are looking for the value of k. All right. Now, look at this uh, equation. This equation has to the power 4 into the power 2. So we are going to take an arbitrary letter. I love to use alpha. Let's say alpha is equal to k squared. Okay, so meaning that we can rewrite the polynomial as k squared minus 8k squared minus 9. Okay, and we said okay, this is just equal to 0, and we said alpha is equal to k squared. So where there is k squared, I put alpha. So this is alpha. This is the squared that is outside. This is minus 8. Alpha minus 9 is equal to 0. All right. So you can see that the product here is negative 9 and the sum is negative 8. So this is just 8 squared minus, you could, all right, so this is just minus 9 alpha. You can just say plus alpha minus 9 is equal to 0. Okay, so I'm just factorizing, and this is alpha outside. I remain with so I factor out alpha, I remain with 1 minus 9. Sorry. I factor out alpha, I remain with alpha minus 9 plus, just factor out 1 here, I remain with alpha minus 9 is equal to 0. So alpha minus 9 is common, I factor it out and remain with alpha plus 1 is equal to 0. So this implies that alpha is equal to 9 or alpha is equal to negative 1. Now remember we said alpha is equal to k squared, so we're just saying k squared is equal to 9 or k squared is equal to negative 1. But we know that, let me start with this left side. So if k squared is equal to 9, meaning that k is equal to positive or minus 3, then all k is equal to, this is plus or minus I, because this is an imaginary number. But remember, we said our k is a real number here. So meaning that our k plus or minus I will not be a solution in this context, but the solution is k is plus or minus 3. So this is how we solve these questions. The only thing that you need to remember are these basic definitions. In a nutshell, x minus c is a factor of a polynomial if and only if the polynomial evaluated at c gives you 0. The remainder theorem says if f of x is divided by x minus a, then the remainder is given by f of a. So you can play around with these things and you can use synthetic division, you can use long division, and prepare for your exams. Thank you for watching. Please like and share for more videos.